Lauren, thanks for sending in another question. It looks like we are solving an inequality, with a quadratic equation in it, and not only are those tricky to say, they are tricky to solve. So we have a 5-step process we're going to follow over here, and we're just going to go one step at a time. The first thing we need to do is set it equal to 0. It looks like I have a negative 11 on the right hand side, so I'm going to add 11 to both sides and combine like terms, and what we'll end up with is negative 8x squared minus 14x plus 15 greater than 0. We're now done with step 1. Let's move on to step 2. We have to factor the quadratic equation here. Notice that there is a negative 8 in front of the x squared, so this is a little tricky. We can't just factor this in the usual way. There are lots of ways to factor quadratic equations that have a number in front of the x squared term. I'm going to do it using the star method. If you have not been introduced to that, just follow along as best you can. So what I'm going to do is I'm going to draw a star. It looks like the X that you're probably used to drawing, but there's also a horizontal line through it. We want to multiply the outside terms, negative 8 and 15, and put them in the top piece right here. So negative 8 times 15 is negative 120. And then we want to go ahead and take this inside piece, the middle piece, and we stick it in the bottom. So negative 14 down here. And then we just take the term in front of the x squared, negative 8, and we stick that on both sides on the top. So we are looking for two numbers that multiply to negative 120 and add to 14. I know that my factors are going to be one positive factor and one negative factor because they multiply to a negative number. I also know that the bigger number is going to be the negative number because when I add them together, I get a negative number. So we're going to start by factoring 120. This factors into 12 and 10. Just start anywhere. It doesn't really matter. You can factor by 2 or 4 or whatever you want. And I know that the bigger number is going to be negative. So what I'm going to do is write these over here on the side and assign the bigger number the negative number because I already determined that. When I add those together, it looks like I get negative 2. I do not get negative 14. So I'm going to keep factoring. I'm going to factor 12, though 10 also factors. It's kind of just something you do by trial and error. So 12 factors into 6 and 2. That means if I take 6 and 2 times 10 is 20, and I multiply those together, and one of them is negative, I would get negative 120. And I know the bigger number is negative. So if I add these together, positive 6 minus 20, that does indeed give us negative 14. So those are our factors. I'm going to go ahead and write my factors in the remaining pieces that are left here. It doesn't really matter which one you write in which. Just go ahead and fill them in. Then I'm going to box these pieces on the side, and I'm going to reduce them just like they were fractions. So if this were a fraction, negative 8 over 6, I would reduce this to negative 4 over 3. Over here on this side, if I were given this as a fraction, negative 8 over negative 20, I would reduce this to, the negatives will cancel. We would get 2 over 5, it looks like. The next step, for the number on the top, I'm just going to go ahead and put an x next to it. These are my factors of my quadratic equation, but they're written vertically. So instead of writing them vertically, I'm going to write them horizontally. Negative 4x plus 3, that's a positive 3, and 2x plus 5. And that's still greater than 0. I'm just rewriting this in factored form. So that's step number 2. The third step is I need to solve this equation as if it's equal to 0. So what I'm actually doing is I'm setting my factors equal to 0 and solving the equation that way. So I'm going to solve for each of these factors equal to 0. So negative 4x plus 3 equals 0, or 2x plus 5 equals 0. So solving this one, you may be able to do that in your head at this point. If not, go ahead and work it out on paper. But if you do solve this, you'll get x equals 3/4. And for this one, we'll get x equals negative 5/2. If you want to rewrite this in decimal form, as it's given in your answer at this point, that's perfectly appropriate. So we'll get x equals 0.75, or negative 5/2 is equal to negative 2.5. That's step number 3. Step number 4 is we're going to create a number line. So let's go ahead and do that down here. Here's my number line. And I'm going to mark off the places where my equation is equal to 0. In other words, at these numbers I just found right here. So x equals negative 2.5, I'm going to mark off. And x equals 0.75. Then I'm going to go ahead and to figure out what type of line I'm going to be putting through those points, I'm going to look at my original inequality. If it's just a greater than, I'm going to be putting a dotted line. If this were a greater than or equal to, I'd be putting a solid line. This is just to note to myself that I'm not going to include these particular points in the final answer. That's step number 4. So now we're on our last step. Very long process. Hang in there. We're going to use some test values, and then we're going to use sign analysis to solve our equation. So what we have here is a number line divided into 3 parts. I'm just going to go ahead and pick a convenient number in each of these intervals that I've created, and then I'm going to plug that particular number into my factored equation. That would be this one right here. Let's go ahead and box that. I'm going to plug it into the factored equation right here, and I'm going to just put the sign of my factors in. So let's give it a shot so you can see what I mean. I need a number that's greater than negative infinity and less than 2.5. Let's go ahead and pick negative 3. That's super convenient. Something in between negative 2.5 and 0.75. Let's go ahead and pick 0. That's very easy to plug in. And then something greater than 1 and less than infinity. Let's go ahead and pick 1 because that's also super easy to plug in. So I'm going to take negative 3 and plug it into this factored equation right here, the one that's boxed. If I plug in negative 3 for my first factor, negative 4 times negative 3 would be positive 12, plus 3 would be a positive number. You don't even have to figure out exactly what number it is. You just have to figure out whether it's positive or negative. If I plugged negative 3 into my second factor, negative 2 times negative 3 would be negative 6, plus 5 would be a negative number. So I would have a positive factor and a negative factor in that case. Let's go ahead and try it with 0 and then 1. If I plug in 0 into the boxed equation right here, it looks like I would get a positive factor for my first factor and a positive factor for my second factor. If I plug in 1, I would get a negative factor for my first factor because it would be negative 4 plus 3, and I would get a positive factor for my second factor. So now we're going to go ahead and use sign analysis to solve this. We need to look at our original equation. They're asking us to find the places where this equation or this expression is greater than 0. So it has to be positive. It's not even allowed to equal 0. It definitely has to be positive. Well, if I have a positive and a negative, I'm really ending up with a negative. So I'm going to cross out that whole area there. Also over here I have a positive and a negative. So all of my answers over there are going to be negative. Positive and positive, that is positive. So it's this part in the middle that's actually the entire solution to my equation. So it looks like everything greater than negative 2.5, not greater than or equal to, just greater than, and less than 0.75 will give me a true statement in the expression that they gave us up here. So this final part right here is the solution to your problem. Thanks for hanging with me, and thanks for sending in another question. I look forward to answering more of your questions using SnapMath in the future.